Yeah. Now we have covered the very first type of quantifier, that is question mark, which indicated about whether that pattern is present either 0 or 1 time. So now we move on to most generic case of that, that is hashtag or a star character, which will try to find 0 or more. So there is a niche difference between 0 or 1 or 0 or more. So how does it matter? So here you could clearly see that this AB question mark, it will try to find out this B right after A, and it has restricted to 0 or 1. Even though this text ABBC has ABB two times, it has restricted to either 0 or 1. That's why it has yielded me AB. What if I use 0 or more, that is star instead of a question mark in the pattern? So what does this affect on the search result? Just have a run on it. So you could clearly see that for, for the first two things, that is AB star in the AC and ABC, so it has yielded the same result. It has found A 0 or more time, AB 0 or more time. Now the trick is over here. So in the text ABBC, when it try to search ABB star, so AB star, so what does it is trying to do now is, so it is trying to find A and B. So try to find B either 0 or more times. So exact this particular term B is present two times over here. So that's why it has yielded the result ABB. So I could just identify one thing over here. So this is the pattern. So the pattern should be A and B. So this B should be present either 0 or 1 time in this case, whereas in this case A and B star. So B should be present either 0 or more times. So that's why it has yielded me the result ABB. Suppose if I write this as ABB, like say if I write it for the very how many times? 6 times say. So A B B B B B B. So very 6 times if I write it, and if I run this search operation, it could clearly yield me that B appearing very 6 times. So that is what this star is trying to do. It is trying to find that pattern B, that is A. After that B should be present either 0 or more times. So this more time represent how many times that particular B is occurring in the given test. So that is how it has yielded me the result A B B B B B. So this is about 0 or more. Now we move on to another type of quantifier, that is plus. So what does this plus do? It will try to identify the given pattern or a given character, whether it is present either one or more time. So it is more sophisticated on top of these two. So this is a 0 and 1 case, 0 and more case. So even though the pattern AB star, so even though the search pattern couldn't find B soon after uh, A, in this case that is AC, it couldn't able to find this B, right? So but still it is a star. The condition says that it should be present either 0 times or more times. Then it has yielded me the very first thing, that is only the A. But now we are restricting very more sophisticated way, that is it should be either present one or more times. That means in the very first case, our very first case should yield me the result that it has not found B character soon after A. That is A B plus indicates you have to find a character or a string where B should be present either one or more times. So now just have a look on it. We'll clearly see that it has not found, because in this string, or in this in this string AC, or in this text AC, it couldn't able to find B appearing one or more times. But whereas you could see that in A, B, C, it could able to find that once, right? So that's why it has yielded me AB. Similarly, in ABBC, it has found ABB, right? So it has found this B two times. So that's why it has yielded me the result. So this one or more time will further restrict, it is more restricted condition on top of 0 or 1 or 0 or more. So these are somewhat a wild way, or a wild character quantifiers, right? What if we want certain expression, a certain regular expression where I exactly want these many number of characters to be present after a given character. Say, suppose now you find me those strings where B should be present soon after the character A for exactly 2 times or exactly 3 times. So these conditions, these quantifiers, question mark, star and plus, wouldn't be qualifying in that case, right? Because this will search either for 0 or 1, 0 or more, or 0 or 1 or more, but it is not specifying exactly the number of times, right? If I want the output only if it is present either 3 times or 4 times exactly, then what can we do? So for these cases we have another set of quantifier, say flower brackets n. So this flower bracket n represent the n over here represent the exact number of matches or exact number of times the character which you want to be present. So that is how it is represented over here. So you could clearly see over here. So I have taken a pattern, the same ABBC, and I have defined this pattern over here in this way. So this is the text where I wanted to search, and this is the pattern. So AB flower bracket n. Here I am defining n equals to 2. So the search should give me the result only if B is present exactly 2 times after A, right? So let's have a look on this then. Yep. So it has given me the result that ABB. Okay. Now let's keep this number 2 as it is, and let's write B B B 3 times and see what happens. Yeah, you could clearly see that it has extracted A, B exactly 2 times, even though that B is appearing 3 times over here. So this is what the restriction comes on top of this. So suppose if I write it as 3 again, then it could easily find that it should extract A, B, B 3 times, right? So suppose if I write 4, what happens? It should clearly give me the result. There is no text found, because in this given input text A B B B C, that is A 3 times B C, and here I am trying to search where B should be appearing 4 times. This is not the case over here. That's why if I run this, it should give me the result not found. So this is how this quantifier flower bracket n works. So we'll move on to the sophisticated search or sophisticated quantifier on top of this flower bracket n. So what if we want, say, I want the characters to be present in a certain range, say 2 to 5 times, 2 to 6 times. In such case, we have a liberty to use the very next quantifier, that is flower bracket m comma n. So it is same, the flower bracket and the syntax remains same, but here we try to define two variables, that is m and n. The very first letter m represents the starting number or the starting range, and n represents the ending range. So you could clearly see that this matches a character is present from m to n number of times. Okay, so I have taken very such generic examples over here. So the very first thing, find pattern a some number of times of b and c. So now your task is to find a b. So if in a given text, if b is present within the range 3 to 5, so then print out or extract the text. So only it will extract from 3 to b is from 3 to 5. So let's have a look at that once. Yeah, so you could clearly see that even though 1 2 3 4 5 6, even though we have b appearing 6 times in a in this particular text, since we have defined the range from 3 to 5, it could able to extract from 3 to 5. So this 5 is an upper limit, so it will not consider this 5, but it will consider 5 minus 1 times, that is 4, right? So this is how a list or any set operation or a list operation will consider. So this, it will not consider the outer boundary, right? So it will consider one step behind the outer boundary. So that's why it has extracted a b b b b. So it is the outer boundary, right? So that is how it has extracted the complete form, right? So it has started from 3 and ended up to 5. So this is how the number of times should work, right? So I have by mistake said it is about list, but this is our regular expression, right? So this regular expression will definitely consider the upper boundary or a upper limit as well. So it has given me starting from 3 to 5. So it has extracted 5 times b. So what in the next example? So the same, I have given a b appearing 6 times and a c, but I am defining a range as 7 to 10. So a and b, so b should be appearing 7 to 10 times, but I haven't defined 7 to 10 b's over soon after a. So this should return me the result not found. Yep, could clearly see that it has returned me the result not found, because there is no range or number of b's appearing in the range 7 to 10. Similarly, you can have a try on different ranges over here. So I have defined one of the thing where I have just given a comma and a 10. So I am not defining the starting range. So it can start from 0 and should end with 10. So it should max, like it's another way of defining this previous quantifier, right? So here we just defined the number 4. So what does this 4 represent? It should represent, it is representing b should be appearing exactly 4 times. Exactly the same here. So find the b's which is appearing exactly 10 times. That is what it is trying to do. But the uh, what we can say, the trick over here is, if we just define 4, it will try to search exact number. So it will try to search b appearing exactly 4 times. But what if we give just a comma and a 10? It will try to consider that comma, the number just before the comma would be 0. So it is same as writing 0 to 0 comma 10. Instead we can just write it as comma 10. So it will try to get the result where b is appearing between the range 0 and 10. So you could clearly see that. Yeah. So since the upper boundary is 10, so we don't have 10, right? So but the down boundary or the lower boundary is 0. So that's why it has given me the result a, right? Because it is not satisfying the condition appearing to be 10 times, right? So that's why it has considered the first boundary condition, that is 0. So yeah, in this case a, after a there is 0. Yeah, That's why it has given me the result. What if I reverse this condition? 10, 0. What does this indicate? The range or number of times b should appear should be starting from 10, infinite times or unlimited number of times, right? So then this should return me not found, because there is no number of b's appearing starting from 10 and ending up to unlimited, right? So this is not the case. That's why it is given me the result not found. You can just have a number of examples. We can try it out with number of examples, changing the numbers, the starting and the ending limit, and we can have a look at how this particular quantifier works. So we have just covered these number of quantifiers. That is the very first one, that is question mark. The next one star, plus, flower bracket n, flower bracket mn. So this question mark indicates 0 or 1, star indicates 0 or more, plus indicates 1 or more, then flower bracket n indicates the exact case type matching, then m comma n represent range matching. So these are all the quantifiers which we incur when we try to apply that on the regular expression dot search function. So we will try to dig more and more other certain expression limiters in the further session.